you're asking yourself, why in the world do I have to take statistics? I'm scared of math. I hate it. I'm terrible at it, and I'm never going to use it. Well, short answer is, hey, first of all, you're already doing statistics. If you can tip your waiter or waitress, congratulations, you have done statistics. If you watch the weather report and understand what it means when they say there's a 30% chance of this, congratulations, you understand statistics. If you play fantasy football or baseball, congratulations, that's all statistics. So this is not something new to you. This is not a new concept. You already engage in statistics in your daily lives. We're just going to break it down, explain it a little better, and show you how to do it. Answer 2 is, hey, we expect you to be researchers. And as researchers, you're going to engage in your own research, or at a minimum, you're going to read some. You probably already have. Have you had papers due? And you had to find X amount of peer-reviewed sources from journals, right? And you're seeing things like alpha levels and confidence intervals, and you're like, what the hell is this? I'm going to explain it to you. I want you to be able to, at a minimum, read research when you get out of here and know what it means when they say statistically significant. That's why you have to learn. Ideally, you'll get out, you'll research on your own, you'll create your own results, you'll know if something is working in your own practice or your own field, but at a minimum, you can read what other people are doing and have an idea of what they're saying. 2 types of research, quantitative and qualitative. Quantitative, we deal with variables. They have to be measurable. They have to be observable. We have to define them well. Quantitative gives us numbers that we can mess around with. Quantitative is objective. There's no value to it. There's no bias to it. If I'm interested in how many people run this red light out here, I'm going to count every single car, and not just the cars from Ohio, because as a value, I think Ohioans are terrible drivers. Did I just insult anybody from Ohio? Okay, good. It is value-free. It's objective. Qualitative, on the other hand. Qualitative is research from the perspective of those who lived it. We put ourselves in someone else's shoes and try to understand how they explain, or how they deal, or how they feel, or believe, or think. It's not numbers. We gather a lot of information and look for patterns and relationships. It can be somewhat subjective. Qualitative is not necessarily objective. There is some value to it. Guess which one we're going to be doing in this class, quantitative or qualitative? Quantitative, because it's statistics. It's a math class. We're dealing with numbers. We're going to be working with quantitative data for this entire class. This is not a class about qualitative. You will learn more about qualitative in your research methods classes. Key terms for you. Variable. The simple definition of a variable is anything that varies. Anything that varies. Explanation is right there in the name. It's a little harder than that. It's anything that we can define and measure that varies. Like love is something that varies. Love is really hard to break down and define and measure. Gender, that varies. We can break that down. We can measure that. We can define it. GPA, satisfaction level with your parking space this afternoon. All of those things we can break down, we can define, and we can measure. So when I say variables, it's the things that we're studying that vary, things that have to be definable and measurable. Hypothesis, which we will get into later in the semester. Our hypothesis is the statement we make about a relationship between our 2 variables. Statement we make about the relationship between our 2 variables. A causes B, or A influences B, or if A happens, B will happen. Those are our hypotheses. Then we've got for our independent variable and dependent variable. We take variable, we break it down. Independent variable is the cause. Dependent variable is the effect. Make sure you put this in your notes. Independent variable, or IV, is the cause. Dependent variable, or DV, is the effect. If you are a visual person, here. So our independent variable causes, impacts, influences our dependent variable. We're going to practice on this today. Make sure you've got this in your notes. Independent, influences, causes, impacts, dependent. We got it? Yes? Got this in our notes? We ready? All right, hypothesis. To test a hypothesis, to figure out if A causes B or A impacts B, well, we have to test hypotheses because logical, common sense, self-evident assumptions aren't the same logic or common sense or self-evident things to everyone. I don't know if you've ever heard this, but what's common sense to you isn't common sense to everyone. Have you heard that? Yeah, have you seen that? Yeah. We have to do hypothesis testing. We have to prove things through statistics because what you think or feel or believe or has been told is not necessarily true. What's true is true. What the data tells us is what the data tells us. We have learned things like, hey, vaccinations cause autism. That was a big thing for a while. It is absolutely proven to be untrue. It is an absolute, utter lie. But there was research out there that said, hey, look, it's logical, right? We're giving more vaccinations. We have more kids with autism now on the spectrum. Therefore, obviously, vaccinations are causing autism. Untrue. We hypothesis test to prove that things like that are untrue. Marijuana is a gateway drug. Also, yes, well known and believed for a long time. Kids who start marijuana will eventually end up on heroin. Not true. Utterly false. Wrong. Statistically, that has been proven to be false. But it's still a belief because it's logical. It's common sense. Oh, they're starting drugs early, they're going to go on to other drugs. Marijuana is not a gateway drug. Scared straight programs. Start with little juveniles who had offended in some way, shape, or form, right? We took them to jail, and we let them meet the biggest, meanest convicts that we could find, and they would scare them. And they would be like, your life is going to be hell when you get to jail. You're on the wrong path, son. You better turn around. You better do good with your life. Based on logic, right? Based on common sense. Let's make kids think that jails are scary. Let's show them that it's hell, that they don't want to be there. Yeah, they didn't work. They didn't work at all. Scared straight programs statistically do not do a thing other than make kids less afraid of jail. So logic, common sense, things that we think, of course this is true, it has to be true. It's not true unless we can prove it's true. And what we're finding out is that a lot of things we thought were true were false. They're not true. So you're learning statistics so that you can read studies that say things like vaccinations cause autism, or marijuana is a gateway drug, or all terrorists are foreign born. And you can look in those studies, read through them, figure out what they measured, how they measured, who they talked to, and decide if it's a good enough study to be actual evidence or not. So this is going hand in hand with your research classes. Statistics are the numbers that we use to prove or disprove that quantitative research, those numbers. Stages of social research. This is what we do. First of all, we take a problem and we convert it into a hypothesis. Remember that relationship between the two variables? We're going to convert it into a hypothesis that we can test. That's step one. Step two, we develop some sort of instrument that will measure. If we want to capture something like GPA, cool. The instrument's already developed. A GPA is a GPA. If we want to measure something like your satisfaction with your parking space, we're going to develop a survey. that'll measure it with a couple of different levels you can choose. So we make it a testable hypothesis. We develop an instrument that we can measure. We collect the data, actually go out and ask the people using our instruments. We analyze that data, step 4, which is what this class is about. This is the analysis class. And the last thing that we do is we share. We do research and share it because we don't suck as people. Because we want to make sure that when something is known, it's known to everyone and we don't keep it a secret. So that's our 5 steps. This class focuses on step 4, analysis. All right, take good notes. This is where it becomes important. We've got independent and dependent variable in our notes, right? Independent is cause, dependent is effect. Well, let's talk about variables a little bit more. Every variable, both independent and dependent, have a level of measurement. There are 4. For social sciences, we combine 2 of them and work with 3. There's nominal, which involves naming. Nominal, naming, it's names only. We've got ordinal. Ordinal is names, but we also have some order to them. And we've got interval and ratio, which put people in categories. There's order to it, and there's equal distance. So let's break those down, explain those a little bit better. Nominal, name only. Nominal variables just categorize people. Nothing is better or worse. Nothing is higher or lower. These are just categories. So something like your gender, male, female, prefer not to answer, no one is better or worse than anyone else. Those are just boxes that you can put yourself into. Race, white, black, Hispanic, Asian, other, mixed. No one is better or worse. You can't do math with these because no one is higher or lower. They're just categories. Political party, Republican, Democrat, Independent, Mountain Party, Green Party, however many there are. Again, there's no order. You can put Green Party first or last. You can put Republican first or fourth. It changes nothing. No one is better or worse than anyone else. So nominal variables, it is nominal if it just categorizes people, if it just gives them a box to put themselves into. No box is better or worse. No box is higher or lower. It is just a box that describes you. If there is only 2 answers, then it's nominal. If it's a yes-no question, are you happy with something, yes or no? That's nominal. Because you can go yes, no, you can go no, yes, it changes nothing. So if we're defining a category and there's only 2 boxes that you can put it in, it's automatically nominal. Things like marital status, things like sexuality, things like eye color, things like hair color, things like occupation. Again, these are just descriptives. These are nominal. No one is better or worse than anyone else. So if our variable is we're comparing eye color and GPA, eye color is nominal. Blue, green, brown, hazel, purple, red. I don't know how many eye colors there are. It doesn't matter. No one's better or worse. We are just asking people to put themselves in a descriptive box. We got nominal. We'll see when we practice. Is that what I'm reading off your faces? Okay, let's move onward. Ordinal. Ordinal's the trickiest one. Ordinal. Scores do rank. There is a highest and a lowest, or a most and a least. So they do go in order. There's an absolute order they have to be in. Survey questions are ordinal. Rankings are ordinal. The thing that ordinal doesn't have, I want you to think of this in terms of 2 things and write both of these down. Ordinal doesn't have what we call equal distance. There isn't equal distance between all possible answers. Hopefully that'll make sense in a second. For ordinal, also think of things that are subjective. Rate your scale or rate your level of pain on a scale of 1 to 3. That's ordinal. What I might call a 2, someone else might call a 3 or a 7. Rank your favorite professors from 1 to 5. That's ordinal. It's subjective. I may rank one professor first because they never have class and it's awesome, or I may rank another professor second because they're really good and I really like them, and somebody else may flip-flop it and rank the professor who never has class last. It's somewhat subjective why we're ranking them. We're talking about our favorites. What's your level of satisfaction? Most satisfied to least satisfied. What's your level of agreement from completely agree to completely disagree? We all might define those a little bit differently. Is that making sense with the equal distance? You got to give me faces even if you don't say anything. Yes?
Ordinal more like opinion.
Ordinal can be opinion. If it's opinion and the answers go in order, it's ordinal. If it's an opinion like, what's the best profession? Sure, that's ordinal. Things like ranking, things like rating, those are ordinal, but not necessarily. There are some non-opinion based that are ordinal. Races, right? You run races, there's first place, there's second place, there's third place. That's not an opinion. Those are actual places. But there isn't that equal distance. The person who came in first may have been 4.5 minutes faster than second, but second may have only been 1.5 seconds faster than third. So that's ordinal because there isn't that equal distance between it. If I'm doing age categories and I say, how old are you? 18 to 25, 25 to 30, or older than 30. That's ordinal because there isn't equal distance in all of those age categories. Does that help explain the equal distance? Ordinal's the toughest one. We're going to talk about it all semester. Other examples of ordinal. If we're talking about grades in terms of A, B, C, D, and F, that's ordinal. An A is 90 to 100. That's 11 points. B, C, and D, those are all 10 points. 80 to 89, 70 to 79, 60 to 69. F is 0 to 59. That's 59 points in an F. So there isn't equal distance in all of those grades. That makes it ordinal. It has to go in order. A is absolutely better than a B. B is absolutely better than a C. But there isn't equal distance between them. If I ask you about your education, tell me how educated you are. And your choices are some high school graduate, some college or college graduate. That's also ordinal. Because some high school may be, I showed up on the first day and quit. Maybe it's I went until my senior year and dropped out. Maybe it's I was a week and a half from graduating and just got sick of it. It's some high school. It's a giant interval. There isn't equal distance between that and the next option, which is high school graduate. Same with some college. Did you show up for a day, a month, a semester, 2.5 years, 3.5 years? What is some college? There isn't equal distance between some college and college graduates.
You're saying there isn't an equal distance?
Is not, yes. Ordinal has no equal distance. So think of it in terms of looking at equal distance and or subjectivity. If you see things like rank, if you see things like rate, that's a clue that they're ordinal. If you see agree, and it's a scale of agree to disagree. Or if you see satisfied, and it's a scale of very satisfied to very unsatisfied, those are ordinal. Same with the race that we just talked about. Not necessarily a race, a spelling bee, whatever. Something that ranks first place, second place, third place, fourth place. Those are ordinal. Movie ratings. Movie ratings are ordinal. We've got G, we've got PG, PG-13, R. Where is it at now, NC-17? Is that right? You're all, okay. None of us know. We're all good. Those are ordinal. They have to go in order. We know that a G is way more appropriate for children than an NC-17. At the same time, this is decided as a body of movie raters, and they don't say like the difference between PG-13 and R is 4 F words and a penis. It's not rules like that. It's somewhat subjective, but they still go in order. G most appropriate for children, NC-17 not appropriate for children, but not that equal distance. I see a lot of puzzled looks. How are we doing? What are we thinking?
I thought that you said ordinal was equal distance.
Ordinal is not equal distance. No equal distance. Not equal distance.
Okay, I wrote this.
Somewhat subjective, yes, or not equal distance. And I may have said it. I'll listen on the tape later. If I messed up, I'm sorry.
No.
Ordinal is not equal distance or subjective. Interval ratio. Those are two different. In social sciences, we get to smash them together and treat them the same. Interval / ratio. Same thing for us. Interval ratio goes in order, does have equal distance. And that is equal distance between every possible answer. Interval ratio will always be numbers. If it's words, you know automatically it is not interval ratio. It's going to be nominal or ordinal. It's got to be numbers for interval ratio. Think in terms of things we all define the same. That'll help you think of equal distance. Age in years, income in dollars, number of children. Those are things we all define the same way. A year is a year to all of us. If I say, how old are you? And somebody says 17, that means the same thing to all of us. If I say, how many kids do you have? And someone says 2, that means the same thing to all of us. If I say, how much do you make each year? And someone says $32,000, that means the same thing to all of us. There's equal distance between $1 and $2, $2 and $3, or between 1 hour and 2 hours, 2 hours and 3 hours. But think in terms of things that we all define the same way. If you're interested, and you don't have to write this down, this is just for your knowledge. If you care, the difference in interval and ratio is that ratio has a true 0 point. So something like number of children is a ratio because there's an actual 0. You can have a lack of children. Something like temperature is interval because a 0 temperature doesn't mean we have a lack of temperature. It means it's freaking cold. So there's no true 0 point if you care. If you don't, just remember we smash those up. We treat interval and ratio the same in the social sciences. So some more examples for interval ratio. Height in inches. We all define an inch the same way. Weight in pounds. We all define a pound the same way. Temperature. 32 degrees means the same thing to all of us. 77 degrees means the same thing to all of us. We know what that means. It may be hot to some people, it may be cool to others, but we know what 77 means. 77 degrees is the same to all of us. Numeric grades. Remember, ordinal was A, B, C, D, and F. Your actual numeric grades are interval ratio. 100, 98, 92, 75. Your actual numeric grades. Those are interval ratio. Number of anything. We talked about number of children, number of cars in your driveway, number of hours you spend studying each night. Number of blank. It doesn't matter what the blank is. If it starts with number of, it's interval ratio. Because it's going to be something we all define the same way. If you say number of kids, we know exactly what that means. Number of pets, you know exactly what that means. Nobody's figuring out like, well, I've got 1.5 dogs. Because one's sort of a neighborhood dog, but he comes and sits on my porch sometimes and I feed him a little bit. Like, no. You have 1 dog or 2 dogs. We all define it the same way. Nobody's being subjective about that. Nobody's putting their values into it or opinion. You have a dog or you don't. Do you have those? Nominal, name only, just categorizes. Ordinal, they go in order, but they're somewhat subjective. There's not that equal distance. Interval/ratio, they go in order and there is that equal distance. It's things we all define the same way. Got it? Okay. So if we were looking at something like pain, if that's our variable, we want to look at the relationship between, let's say, gender and pain. Well, pain is something we could measure on any of those three levels, nominal or ordinal or interval ratio. I wanted to do nominal and measure pain. I could ask a yes/no question. Are you in pain? Yes or no? We know that yeses and nos, if the question is answered by a yes or a no, we know that's nominal. Or I could say, hey, how would you characterize the type of pain? Sharp, dull, throbbing. None of those are better or worse. They're all pain. They all suck. You don't want any of them. Nothing's better or worse. It's just a category. You are categorizing the type of pain that you're feeling. So if we're looking at pain as a variable and it's asked about in one of those two ways, it's nominal. Okay? So ordinal. Remember, it goes in order, but it's somewhat subjective. There's not that equal distance. Okay? So how bad is your pain right now? None, mild, moderate, or severe. They go in order. Severe is always worse than none. Right? Mild is always more than none. There has to be an order. None is the lowest. Severe is the highest. We've got mild has to go after none, and moderate has to go before severe. They go in that order. But there isn't equal distance. There's not exactly 5 points between those. Or 1.5 headaches. There's not an equal distance between them. They're somewhat subjective. What I might call mild, someone else might call none. Or someone else might call severe. There's that subjectivity. I could ask compared with yesterday. How is your pain today? Less, about the same, or more? Again, those three answers go in order. Less is always less than more. Less is always less than the same. More is always more than the same. They have to go in that order. But there isn't that equal distance. You're not checking off a list and saying, well, according to my checklist, it's exactly about the same. There isn't an equal, according to my checklist, now I'm at more pain. It's somewhat subjective. There's not that equal distance. We're not counting blocks and putting ourselves here or here or here. They're not equal. They're somewhat subjective. Pain is a tricky one to measure on the interval ratio, but your doctor will try to do it. Have you all seen this scale? Has anyone seen this scale at the doctor? Yeah. This is doctors trying to measure pain on an interval ratio level. So they'll do a scale of 0 to 10 or 0 to 25, depending on the doctor, and ask you to pick where you are. And they are putting equal distance between it. They're doing their best to say, hey, one more step above this one. Hey, one more step above that one. They're doing their best to say there is an equal distance in here. They're putting some faces so that, hey, if you're crying, you know that you're on this side. Or, hey, if you're smiling, you know that you're down there to 0. So that's how we would take something like pain, and we could measure it at any level of measurement. Nominal, ordinal, or interval ratio. There are times that you will see us treating some variables that are technically ordinal, we will treat like interval ratio, like pain that I just showed you. The reason is we can do a whole lot more statistical processes with interval ratio level variables than we can with ordinal. So there are some that I'll ask you what's the level of measurement, and you'll tell me ordinal and you'll be correct, but we still do a higher level test for it. You're right. I just don't want you to think you're wrong. You're right. Ordinal is the subjective or the non-equal distance, but we're going to treat some of them later on in this class as interval ratio so we can do all the fun stuff with it. All right, we're getting close to the end. You're doing good. Hang in there. 2 more things to think about in terms of variables. There's continuous and there's discrete. Discrete is easy. They are separate, distinct categories. You can put yourself into one box, and only one box, and you're finished. That's it. We're done. We're good. Things like eye color, things like gender, describe your pain. Was it dull? Was it sharp? Was it throbbing? Those are all, boxes. We put ourselves in the box, we're finished. Continuous, that's a little bit trickier. Continuous has to be something with like decimal places. That's continuous. Things like weight, I could tell you my weight in pounds. I could tell you my weight point something. I could tell you my weight point something. I could keep infinitely going. If you've been around little kids and you've asked them how old they are, little kids are the perfect example for showing how age is a continuous variable. I would say like, hey, I'm 37. Little kids will be like, I'm 5 years, 4 months, 6 days, 2 hours, right? Yeah. 3 minutes and 42 seconds old. It's infinite, the amount of time that they can go out, the amount of decimal places they can put on there. So something like weight or age are continuous. We can have infinite decimal places after them. Discrete is when we put people into a box and that's it. There's no continuing. We're not putting decimal places after it. Okay, so this is what we're going to do in class. This is what our semester will look like. Early things we're going to learn how to do. Describe data. When we come back next week, we're going to learn frequency distributions, graphs, charts. After we finish describing data, when we move on towards the middle of the semester, we learn to make inferences, to make generalizations, to take our data, test it, and see if we can apply that outside of just the people that we talk to. So that's our lofty goals this semester. These are the things that we're going to follow. You made it through your first lecture. Let's summarize, and then you're going to practice on a worksheet for me. In summary, researchers using systematic rules, numbers, tests, allows us to know what's true, what's actually true, not what we believe to be true. We follow rules when we're doing statistics, when we're looking at our quantitative research. We follow rules so that we can say something is true, or so that we can say it is untrue. Next thing we're going to learn when we come back next week is how to describe data with statistics. It'll be great. We can take a sample of 4,000 people, we can collapse it to a chart, and you know exactly what's going on. So, get excited. Descriptives are up next. No? Okay. For the shot. Here's what we're going to practice today. Hopefully you took good notes. I'm going to hand you out a worksheet. The front will be word problems. You will be reading through the word problems. Generally, the first sentence or the last sentence, usually the last sentence, will tell you what you need. You need to find the two variables, independent and dependent. What are the two things we're looking at? Which one is the cause? Which one is the effect? Cause is independent, effect is dependent. After you pulled out your independent and dependent variables, then you're going to tell me the level of measurement. Nominal, if it's categories. Nothing's better or worse than anything else, it just categorizes. Ordinal, if they have to go in order, there is a better and there is a worse, but there isn't that equal distance, or they're somewhat subjective. An interval ratio, if they have to go in order, and there is that equal distance. They are not subjective. We all define them the same way. Ready to get started? Okay.